Welcome, everybody. Hopefully you're at the right talk. We're going to be talking about keeping agents in check with Apollo MCP authentication using WorkOS as our identity provider. So let's quickly go over what we're going to be covering in this presentation. We're going to be talking about the why. Auth is always something that's spoken as being very powerful and very important to these sort of situations, but we want to make sure that we understand how does that relate to the MCP space and things of that nature. We're going to start talking about the real world and what it looks like in the current landscape. And then we're going to start just sort of layering on top of that all of the auth primitives that we have available to us using the MCP spec. Eventually we'll go into a quick demo where I'll just showcase that this isn't just hallucinated, that we actually do have something working. And then we'll talk about what we actually did during that demo as a retrospective and possible next steps to see what might be somewhere that you can go next to learn more. So most importantly, let's talk about why. Why is this such an important topic in the MCP space? Well, in order for these servers to be as useful as they are, we have to give them insane amount of power. And so what this power looks like is being able to impersonate us and our agency, having read-write access to our email servers, having direct production access to our metrics. And all of this is very, very exciting, but is also very scary. These servers have way more than they probably should need, but how do we balance that? So the most important thing is that we currently have certain things that all of this power brings with it. And so as I sort of alluded to earlier, we are allowing these agents to act on our behalf. They are taking our agency, but that means without authentication and without all of the primitives that go with it, you have always the risk of having people being impersonated. Phishing, for instance, becomes a lot easier if you have direct access to the email server. And then a lot of what agents work on is unconstrained user input. And so you have to worry about prompt injections. And then even if you have safeguards in the system prompt, there are certain prompts that are very good at bypassing that, like asking to be the grandma, for instance. And then last but not least, the servers themselves could be malicious. There was a very recent case of an prominent email MCP server that was kind of like taking foothold in the market. And all of a sudden, the developer added a one-line change that started BCCing everybody's emails to a server of their control. And so these are all real threats that we need to make sure that we internalize when we are spinning up our own MCP servers and really working with them. And so given this, how do we balance that delicate fine line between powerful enough to actually be useful and constrained enough to make sure that our blast radius is as small as possible? And so what I really want to enforce in this talk is that with all of this privilege, it entails responsibility. So what does that mean in the context of this? So we are giving these MCP clients access to these servers, shown below. And what we want to make sure is that at every step of the process, they are kept in check by the authn and authc primitives above that we will be talking about in this presentation. So now, what does that look like in the current landscape? Well, auth is always a very complicated topic. It's very nebulous. There's many actors at play. So we're just going to quickly go through what the prominent actors are in the case of MCP and this ecosystem. So when it comes to auth, you can think of it as a trio, a little dance, if you will. On one side, we have the identity provider who is in charge of making sure that a user is who they say they are. And so that is commonly referred to as authn for authentication. On the other side, you have our server, who, building off of the reliability guarantees of the identity provider, then follows up that question with, well, how do we then enforce that the person who is who they are is allowed to do what they want to do? Also usually referred to as authorization or authc. And then dancing between the two of them is the client, who has a lot of work to do. The client is responsible for proving to both of these entities that they are who they are and that they can do what they want to do. And so this is great from a more overview of just the typical auth dance. It gets even more complicated in the case of MCP servers because a lot of them are proxies. So besides the entryway, you also have literally everyone else, all of your upstream servers, which might have their own bespoke authentication solutions. And so this is a very complicated dance, right? And so now, given that sort of overview, we can start talking about what is it exactly from the MCP side of things that we can start to layer these primitives onto to sort of navigate this complicated dance. So we're going to start talking now about what that looks like within the MCP sphere. So This is, I promise, the only piece of modern art that I have in this presentation, and it is an overview of how complicated that dance truly is, only within the context of the MCP client-to-server model. So in this case, I'm going to kind of sit on this because while most of this will be transparent to users, I think it's very important to at least understand these basics whenever we start to get to points where we have to debug this. So at the beginning, an MCP client will attempt to make a request to an MCP server. The server will see that there's no authorization header attached to the request and immediately deny it. And as part of that denial, it'll inform the client, hey, you can go to these endpoints to fetch the information necessary to begin this authentication dance. So the client then grabs that information, goes back to the MCP server, and fetches even more information regarding to which identity providers that server trusts. From that information, it then goes straight to the authorization server and continues the dance there. And so what's important here is now this is just a traditional OAuth workflow. And so it'll prompt the user through a browser to log in, make sure that the user grants consent to the specific scopes that might be necessary for this application, and then eventually gives back a token to the client with that information. Finally, when the client has that information, it goes back to the MCP server, now with an authorization header. And the MCP server verifies that all of that information is correct with the identity provider, or the authorization server in this case, and then comes back and allows the process to go through. So yes, very complicated, but again, for the most part, the only thing the user will see is just the redirect, the login, and then the work back. And so now this is all fine and dandy to talk in a sort of like high-level overview, but what does it look like in practice? So what we're going to do is we're going to just do a quick demo just to showcase how we get to the point where we can start doing this. So we can switch over to the demo. Yeah, I'll have to ask more nicely next time. But anyway, so now that we're here, we can just quickly go over to the right spot. And so for the purposes of this demonstration, I'm just going to just quickly show you the steps. If you've gone to my workshop, this will look very similar to what we've done there. But we're just going to start off with what a lot of the other talks have been starting with, which is just an MCP server that understands our API. So for this demo, we just have a very simple GraphQL server running that's connecting to the Metropolitan Museum of Art's collection API that's going to allow us to search for artwork and things of that nature. So here we have on the left, the configuration for the Apollo MCP server, and on the right, the configuration for the router. So I'm just going to quickly start Rover with that information. Is that the right one? No. OK, 1 second. So we're just going to go to the one that actually has the right configuration information. Perfect. And so now we're running on port 5000, the MCP server, and port 4000, the router. This is very traditional and the simple case, right? So now I need to grab we can just do a new window then. And what we're going to do is, don't worry, I will zoom in a second. We're going to go to that instance of the router and just verify that it works as expected. So here we've connected to our local instance, and I just want to get all highlighted works that the Metropolitan Museum currently has on display. So we're going to ask for the title, and we're going to ask for the image URL so we can actually see them. So if we hit this endpoint real quick, we can see, for instance, Cottage Children, the Wood Gatherers, Garden at San Andres, and as follows. So very simple base setup. We have our Apollo router running, and the MCP server is running behind that. So to verify that the MCP server is, in fact, actually running, we're just going to move this back over here. And we're going to run a debugging tool that's written by the people behind the Model Context Protocol specification itself, and it's called MCP Inspector. So it's available through NPX, and we're just going to run that real quick. Going to let that open up my browser. Perfect. And then I'm going to go back to this window, actually. And now that we've connected here, we can connect to our running instance, list the tools, and I have a few just very simple tools here that allow us to see the basically the same sort of thing. So if we just want to get all highlighted paintings, we can hit Run Tool, and there we have it. We have all of these random same paintings that we've asked for before, the Cottage Children, and so on and so forth. So now, from this base setup that has no authentication and no concept of authorization, we're going to start layering on more and more constraints. So the first thing that we can do is quickly apply the next commit that I have in this set. And you'll notice on the right-hand side now, we're going to start mimicking upstream servers that have their own bespoke authorization solutions. And so in the case of the router, we can enable authentication using an existing identity provider, which we will be using later. And we can also enforce that all requests made that are unauthorized get rejected. So now with that out of the way, we can go back here and restart this server. And now when we go back to the MCP inspector, if we try to run get highlights after we reconnect, you'll notice that we get an unauthenticated error. Excellent. We are now at a point where at least our backend is secure. So now let's allow the MCP inspector to talk the same sort of authentication language. So the first thing that we need to do is we need to go to our next commit that I definitely have ready. And if we look back at our config now, you'll notice that we've added this new field for authentication. So the diagram that I showed earlier that showed the entire overview of how that authentication flow works basically works off of an extension to OAuth 2.0 called Protected Resource Server. And that's basically the base for all of the authentication permitted from MCP. So that specification requires a few key points of metadata that this server needs to be configured to expose. The most important ones are the set of authentication servers that we support as being trusted. So this is, you'll notice, the same top-level domain as the, you'll see in a second, it uses the same JWKS endpoint. And then we have to specify, because when it comes to OAuth tokens, there's a few things that need to be verified in order for it to be considered valid. So it needs to be minted for us by a server that we trust and not be expired. And so the way that works is the server that we trust is configured here. The audience is how we can double check that a token was minted for us. And then the server itself will ensure that it's not invalid. And then the last thing that we need to specify is the resource that's being protected. So in this case, that is the publicly accessible URL of our running instance of the MCP server, which is running localhost 5000 right now. And then the scopes, which are the requested scopes that we might want to use within the authentication flow of the MCP server. So for now, I'm only asking for OpenID, which will give us basic profile information. But you could always have more here as you add more fine-grained like role-based access control. So all of that out of the way, we're going to restart now the MCP server. And once that is running, we are going to go back, and I will remember one day that it is that way. We're going to go back and try to reconnect. So before I do that, since we kind of like parked on the overview of the process earlier, the nice thing about this debugging tool is that it actually lets you do that step by step. And so we're just going to do that just to be super sure that we understand the process. So the first step, the MCP server is going to be hit by our client and is going to be denied. So we do that. And you'll notice that it told us, hey, go to this resource endpoint to figure out where to fetch the rest of the information for the client. And so if you look here, here is basically a repeat of the configuration that we have already in the MCP server. And so it's told our client, hey, I need you to go to this authorization server, and I need you to be at least support OpenID for this resource. And so if we check, the next request it made was indeed to that server that we have configured. And this is just typical OAuth discovery information. There's a lot. But the important thing to keep in mind is that it does support the scope that we've requested, which is OpenID. The next thing that happens is in a typical OAuth flow, you'll have a client ID and client secret per application. But since MCP servers are to be deployed basically everywhere, and there's a limited but large set of clients that might need to hit it, so like Claude, ChatGPT, and any other form of like MCP client, the specification requires dynamic client registration. So that's just very fancy speak for saying this client will be able to request its client ID and secret in real time. So if we hit continue, it'll say that it was able to register itself, and the response now has our client ID. Perfect. So we have now finished step one. For step two, we need to actually go through and authenticate. And so in this typical flow, it'll ask you to redirect to the login screen. I will zoom in a lot. For the purpose of this demo, I've made a user that is a potential curator for the Metropolitan Museum of Art. And so it's asking me that the client, in our case, MCP Inspector, wants access to our account. So we're going to hit Allow Access. And now it's given us an authorization code. So when we go back here, this is the last step now, because using that authorization code, the MCP Inspector can request a token. And indeed, we were able to get a token. And this token's interesting. We can always look at it by decoding it using an online JWT decoder. So if we just copy this and go to our little, which I will need to go to, we can see here, if we remove this and paste it, this is what was given to us by our identity provider. And the important things to keep in mind is that our audience is the one that we've configured in the MCP server. So this token was actually minted for us, which is a good first sign. And the second thing is that we have our list of scopes that we have requested. So as we want to add more granular permissions to these subgraphs, we can actually use the scopes. And perfect, then it's verified, it's signed, and it's not expired. So if we go back now to the MCP Inspector, and we go all the way up and all the way that way, because that is a long field, back to connect, we should be able to reconnect now once I refresh this page. And now we're in. And so we've now authenticated with our MCP server. And now when we try to run any of these tools, the router is configured to use the same set of JWKS endpoints as our identity provider provides for the MCP server. So it has validated the token and seen this person is supposed to be doing this and has access to it. And so now if we check, we have access to all of the same data that we had before, but now through an authenticated mechanism. And so this is sort of the prime information that is important for this ecosystem as auth continues to evolve. But now, the most important thing is, now that we have this information, we might have, for instance, set highlighted is something that probably should only be allowed at the curator level. So in the schema, we can use some of the router's authentication primitives in terms of its directives to layer on that set highlighted needs to be done by a curator. And so if we look, for instance, say that we really like this one piece of art. Let's just grab this one, Teasing a Sleeping Girl. Let's see what this looks like. So say we find that this should be highlighted because we just think it's funny. We can grab the ID as a curator. We can go into set highlighted, go through, and see that it works. And so this is now a fully authenticated from end to end and authorized workflow. And so now if we can go back to the slides, rejoice, you made it this far. We now have a server that's authenticated all the way through from front end with our little trio to our back end with the giant haul of upstream servers. And so now let's talk about what actually happened, because there was a lot that happened there, and there was a few Git commands to kind of fast forward through the typing. The most important thing is, once we've gotten our request and we've started the authorization flow, there was really only 4 stages. We started off at our identity provider, which in this case was WorkOS, and we asked, can we log in? We logged in, it gave us a token. Using that token, we went back to our MCP server, which is the server, if you remember, the loot player. And that server now was able to validate that token and say, yeah, this person should be allowed to go through, and it's passed through to our router. Our router then translates that into whatever set of discrete subgraph fetches using that authorization information, which then eventually hits our Met API. And if we look at the config, the only thing we really had to do as a server was just add this information. And so this is a very powerful primitive to now allow for these servers to be hosted in public endpoints and authenticated through identity providers that can be any identity provider that you might be hosting now, or well-known ones like Auth0 or WorkOS in the example of this specific demo. And the most important thing is that we have this configurability between setting our audiences, because perhaps we have more than one identity provider or more than one client that requires a specific audience. And we can also set the servers to a list of any server that the user can at least go through. So if we have like say for instance, there's multiple companies that want to share the same MCP server, they can all allow for different servers to authenticate them. And then lastly, the scopes will allow for more granular control over these access patterns based on the use cases. And the important thing to know about the scopes is that you would want to put all of the scopes you would potentially want here If a client does not have access to a certain scope, it won't be returned with it, but you still need to inform the server about them. And so great, we've made it this far and we've done an entire auth workflow. So what are the next steps? Well, if there's anything else that you should take from this talk, is that AuthNZ is very important and it's our responsibility. But also understand it's a very complicated topic. You saw the workflow. I don't know how many people can look at that and not have their eyes glaze over immediately. So ask for clarification. Auth is a shared responsibility. And as we continue to give all of these MCP servers the necessary power to be useful within the workflows that we envision, we need to make sure that we also keep them in check using these primitives. And so now I will take any questions. We have 2 mics. There's one there. There's one there. If you don't feel like standing up, you can also ask from the seat, and I will try to see you over the lights and point you out. Don't rush the mics, Yes.
Great talk and great workshop. Thanks. I have a question on the dynamic client registration. So is there any guidance on how long those clients should live, given that maybe the workflows come and go?
Yeah, that's a very good question. We found that the typical flow in the specification is to always ask for a dynamic client registration. Clients will cache them once they've been successfully done once, and so it won't make a billion of them in your application section of the identity provider. But the specification is written such that it is tolerant to revocations. So if you want to just have some form of automatic timeout, maybe after a week, a day, whatever your policy might require, it should be fine. Like I said, clients will always start the process from the beginning as they see it, because there's another issue with that the specification is very new and is constantly evolving. So there's a lot of redundancy built into retries and things of that nature. Hopefully that answers your question. Anyone else?
Hey, so I'm asking this question on behalf of some of our customers. During the workshop, one of the questions that kept coming up was, why do we have to define the scope separately in the MCP server config when we have the whole authentication and authorization work happening in the router? So can you shed some light on that?
Yes. So the big thing about the MCP server needing the scopes is that the variant of the OAuth 2.1 specification that is used by MCP servers requires that resource servers define their limited set of scopes, because the idea is that, say you have multiple MCP servers and each MCP server is backed by possibly the same graph but different subviews of the graph, they might not need the same set of scopes across the board. And so you can have more fine-grained access per MCP server to sort of make sure that you aren't giving extra permissions than necessary, because by default it will ask for all of the scopes that the user has available to them at the time where they link with the MCP server, if that makes sense. So it's configurable in that sense because you might still be backed by the same router instance, for instance. Yes?
Hi, I have a kind of a non-technical philosophical question.
Got it.
First time that I saw a dialogue asking me to authorize an MCP server, I felt scared. I wasn't sure what I was authorizing to what. And so I guess my question is kind of about usability and how do we, are there any efforts to make that user experience a bit more comfortable and something that doesn't condition us to just click yeah, and then ultimately get in trouble?
Yeah, that's a very good question. So this is, I think, also just a general issue with OAuth, is people start to get desensitized to these consent screens. The best I've seen is if you can narrowly scope exactly what you want and you can create custom scopes which have their own sort of description, then it becomes a little bit more similar to the mobile style of permissions where it asks you for, oh, I need this for this reason. But it becomes more of a documentation thing than it does so much as a core to the authentication protocol, if that makes sense. But the best thing to do is just have very narrow and very specific scopes that have very good documentation. Hopefully that answers your question. Yes?
Yeah, a little follow-up on that. At what point can you inherit something that is already authenticated? Like if you do like a chat experience on a website that it's going to call on some certain tools, can you be previously authenticated, or that authentication could be passed on to the MCP?
Yeah, that's a good question. So pass-through is a very contentious topic in the specification, but I think it's mostly it's a question of what you define as pass-through. So the specification as it stands today is very strict on what they call opaque token pass-through. So arbitrary tokens that are passed to the client, from the client to the MCP server, and the MCP server doesn't know what to do with them, so it just passes them along. So as it stands today, that is not allowed. But because of the fact that the specification uses OAuth 2.1's protected resource, as long as the token that you have minted anywhere along your previously authenticated workflow has an audience that the MCP server knows what to do with, then it will by default just accept your request. Like the entire workflow beforehand is for cold starts, for lack of a better term, where the client just hits the MCP server directly and then needs to be informed how to do everything else. But if you've already authenticated and you have a token that was minted by an identity provider that your MCP server is configured to also trust, then it'll just trust the token.
So it's more delegated to the audience set?
Exactly. And so that's why the other name that they use for the protected resource is delegated authentication, because unlike previous OAuth 2.0, where the server itself is also responsible for minting tokens based on the previous permissions of the token given to it during the initial OAuth 2.0 flow, this is entirely delegated to identity providers. And the only thing it does is validate that the token is valid.
And who recognizes the audience? I mean, like if you're part of the audience.
Yes, so the audience is configurable from the identity provider's point of view. So whenever you configure a new endpoint, for instance, you would say, oh, tokens minted for this endpoint are meant to target these specific resource servers. And so you can give it an arbitrary list of audiences. And so our MCP server, as part of the configuration, allows you to specify which of those audiences should be considered valid for itself, if that makes sense. So as long as you generate a token that has in its list of audiences your MCP server's configured audience, then it will be considered valid. And this is part of the extensions that 2.1 brings to OAuth to allow for less cumbersome workflows where you have to continually authenticate with every single sub-resource. Hopefully that answers your question.
I have another question on the consent part. So consent is captured and allowed by the authorization server, but is there any guidance whether the authorization server should store the consent and show it to the user? And can the user go back and kind of revoke that? Yeah,
so that's going to depend a lot on the identity provider. Most identity providers that are following the original OAuth 2.0 spec should allow for later revoked permissions. Because typically, if it's a cold start and you don't already have a token, or you have a refresh token and it's going to re-request information, when it redirects you to the identity provider, it should be checking internally that the consent is still valid. It should only ask for consent. Usually, default configuration is it'll ask for consent once on first connection. You can limit that and make it more strict and have it re-ask for consent either every time or on a rolling basis. But typically, it's identity provider specific, if that makes sense.
Thank you, Nicholas.